Howdy, my name is Tyler Burns, and I am the team captain for the University of Arkansas at Little Rock's 2026 AISC Student Steel Bridge Competition team.
And I am Felix Romero. I am a member of the UALR Steel Bridge team, and in this video, we'll walk through the three main phases of the Student Steel Bridge competition.
We will also show you how our bridge has come together through each phase. The first is design.
Design is the first step in any construction project, and it's almost never a straight line from start to finish. What comes out of that process is a redefined design that is strong, practical, and optimized for performance. A complex design might work perfectly in analysis, but fails when it comes time to build it.
For us, this design process began in September when the rules were released. We started by referencing past competitions to better understand the general concept for what our bridge may look like. We quickly began to realize that, although there were many ways to interpret the rules and unique designs seemed to be an integral part of the competition, we wanted ours to stand out in a different way. In order to do that, we decided to develop a bridge that complied with the competition rules while taking into consideration the design specifications that govern real-world steel design. We achieved this by designing stringers to use a W12x14 and scaled connections and fasteners to resemble assemblies at full size. To cut weight while keeping most of the bridge's strength, we designed a Warren-style truss cutout in the web portion of the W shape. Limit states were checked via hand calculations using the AISC Steel Construction Manual. This included stringer yielding and fracture, local torsional and flexural buckling, bolt shear, tear out, bolt bearing, and weld rupture. Once we had a design on paper, Autodesk AutoCAD and Inventor were used for 2D and 3D design respectively. This model allowed us to run Nastran, Inventor's finite element analysis software, to verify our hand calculations. After tweaking the design over a few months, we were finally ready for the next phase.
Next comes fabrication. Steel members are cut, drilled, and prepared for assembly based on the drawings and measurements from the design phase. If parts don't line up correctly, the entire bridge can suffer during assembly, which can cost time and points at the competition. It teaches teams quickly that even the best design only works if it can be built accurately.
For us, the fabrication stage was the most grueling and time-consuming part of the entire process. However, we were fortunate to be sponsored by W&W AFCO Steel, who was generous enough to donate all of our material and allowed us to utilize their state-of-the-art steel CNC machine to fabricate the truss members. To add to the legitimacy of this bridge being a true replica of real-world construction, we took months to draft shop drawings, develop contract documentation, and ensure strict oversight of the safety of all of our members for this entire operation. Also, CNC machines do not run themselves. Because of this, we had to develop the CNC information using Vortman's Vacam design software, which provides code to the machine for it to run. This was certainly the most challenging part of the entire process and required heavy collaboration with W&W AFCO Steel employees. Once the stringers were CNC'd, we started in-house fabricating the splice plates, horizontal braces, and footers, all from the waste material in the CNC process. Yet another way we ensured sustainability in our design. This required members of our team to use, or in many cases develop, their skills in plasma cutting, welding, and many other things to meet the ever-impending deadline. A constant cycle of fitting up, fixing errors, and refitting took place over several months, and even took place all the way up to the day of competition.
Finally comes assembly. Teams must build their bridge under strict rules and time constraints, so speed and coordination matter just as much as strength. From an engineering standpoint, this phase tests constructability. Mistakes in sequencing or alignment can cost valuable time and points.
So, in order to prepare for this, our team has had to practice consistently over several weeks. Although this point in the process is so much shorter than the others, it is the most crucial and requires us to be at the top of our game. The only thing that can truly help is preparing and practicing as much as possible.
So that's a simple overview of what it takes to compete in the 2026 AISC Student Steel Bridge competition.
As you can see, there's a lot of work that goes into building a competitive bridge.
Now we've got to get back to work.
So you best get your spurs on, saddle up, and we'll see y'all at the competition.